Welcome back, Algebra. We are continuing with our interpreting of graphs. Today we're going to interpret extrema and we're going to interpret end behavior. So, interpreting a graph also involves estimating and interpreting where the function is increasing, decreasing, positive, or negative, and where the function has any extreme values, either high or low. So, for example, we're going to start with the outbreak of the H1N1 virus. Seems a little fitting for what we're going through with COVID, but H1N1 virus can be modeled by the function graphed at the right. So, the function at the right. Estimate and interpret where the function is positive and negative. So we're going to look at positive and negative, and then increasing and decreasing. We're going to look at increasing, decreasing, the x coordinates of any relative extrema. So then we're going to look at relative extrema, and we're going to talk about end behavior. So didn't do blue. End behavior. So for a graph to be positive, that means that when we're looking at positive, we're looking at y values. So y values. So if it's positive, it's going to be greater than 0. And if it's negative, y is going to be less than 0. So in this graph, are there any points where y is below 0? So if I extended this x-axis, are there any points where y is below 0? The answer is no. So it's positive from 0 all the way to 42. So 0 to 42, x is positive. But if I wanted to see where is it negative, there's no point where it goes underneath. So there are no negative points. There are no negative. There is nowhere where the function is negative. This means that the number of reported cases was always positive. This is reasonable because a negative number of cases cannot exist in the context of the situation. So increasing. So increasing means, is it going up? So increasing, if you notice, I'm following along this graph, it's going up in this direction. So it's going up in the y direction. So that means it's increasing for the whole thing. There's never a point where this graph goes down because you can't have negative cases. So it's not going down. So there is no decreasing part. The number of reported cases increased each day from the first day of the outbreak, which is how it works. So relative extrema, if you look at this, so right here is our lowest point. So relative minimum is x equals 0. And then at day 42, right, it starts to level out around here. All right, it's still going up, but it's leveling out. So that's called a relative maximum. So at x equals 42 is our relative maximum. And the end behavior, it says that, so if I look at this, my end behavior is where the arrow is, and as x is increasing, as x is going to the right, y is going up. So as x increases, y, in this case, y approaches about 11,000 cases. The end behavior of the graph indicates the maximum number of reported cases of 11,000. So we're going to look at these next problems. They look very similar to what we did yesterday. They're the same ones. So interpret where the function is positive or negative is first thing. And then we're going increasing or decreasing. And then the x coordinate of relative extrema. Let me do that in green. Relative extrema. And then the last one is we're going to do the end behavior. So positive or negative. This graph is always positive. It never goes below. Even though it looks like it's going below, it's going down. However, it does not. It doesn't go below zero. You can't have negative whales. But this is not a good thing. This is the right whale population is going extinct. So it's down to zero. So, it's always positive. So positive from 0 to, what is that, 8, 10. All right? And it's not negative anywhere. Increasing or decreasing. So it's decrease. It never goes up, so it's always decreasing. So it's decreasing from 0 to 10. So we're looking at the x range, the range of the domain from 0 to 10. Relative extrema, there are no relative extrema. I guess we can say that x at 0 is a max at x equals 0 and a min at x equals 10. And then the end behavior, as x approaches 10, y approaches 0. So end behavior says this: as x approaches 10, y approaches 0. And so that's what we're doing for all of these graphs. So looking here, we have it's positive and negative. So we have positive from, I'm just going to put an arrow. Positive is from 5 to 7. 5 to 7 in my x, but it's negative from 0. If you notice, 0 is negative, negative, negative until 5. All right. Increasing or decreasing? Well, so let's do our decreasing first because that's where it starts. So it's decreasing from 0 to 3. So it's decreasing, decreasing. Then all of a sudden it's increasing. So increasing the rest of the way. So from 3 to 7 would be increasing. Next thing we're going to look at is extrema. So we have a min at x equals 3. At x equals 3. If you notice, it's a min. And our max at x equals 6. And lastly, our end behavior as x approaches 7. So x approaches 7. Y approaches about 0.5. About 1/2. If you notice that, that's about 1/2. So we'll put 0.5. I'm going to leave the last one for you guys to do on your own. All right, guys. Thanks. Have a good day. Let me know if you need some help, as always.